Hello, everybody. So this is for Algebra 2, as you guys can see, for finding inverses. So to introduce this idea, you guys have been doing this kind of coordinate tree where they tell you an x or you pick an x, like you pick 4, and then you fill it into the equation to find the y value. So if I take 2 and fill it in, I got 3 times 2 minus 2, 6 minus 2, so your y value is 4. Take negative 3 and fill it in. So that's negative 9 minus 2 is negative 11. We don't need to do the 4. I was just explaining where that comes from. Okay. Now, without telling you why, I'm going to take my answers here and put them over here on this one. And I'm going to take these numbers and fill them in. 4 plus 2 over 3 is 6 over 3, which is 2. Okay. Then I'm going to take the negative 11 and fill it in. Negative 11 plus 2 over 3 is negative 9 over 3, which is negative 3. And what I want to show you is, notice I took a number, filled it in, got an answer, took that number, filled it in, got an answer, and my answer is the same number that I originally filled in. So whatever this equation did, this one undid. I filled in a negative 3, did some work, filled negative 11 into this equation, and it gave me back what I originally filled in. This equation undid that one. And likewise, if I were to pick a number, let's go with, how about 7? I'm going to take 7 and fill it in. 7 plus 2 over 3 is 9 over 3, which is 3. I'm going to take this 3 and fill it in this one. 9 minus 2 is 7. Look, it gave you back what you originally filled in. These equations undo each other. That's what an inverse is. This equation undid this one. This equation undid that one. And there's a notation that goes with it. Now, before I scroll down and show you the notation, you guys are used to, instead of it saying y, it says f of x. Okay? This is f of x. Okay? Now, to tell you to say this equation is the inverse of that one, there's a special notation for it. It's this. If this is f of x and this is its inverse, this is how you, excuse me, hiccup. This is how you say it. And so I pronounce this f of x. That's how I say this. This you pronounce f inverse of x. So I don't say f to the negative 1. This is this. F inverse of x. Okay? That's how you say it. That's how it's written. The inverse is written with a negative 1 looking thing in between the name of the function and the variable. So G inverse X, P inverse M. Okay? These would be inverses of the original function P and the original function G. Okay? All right. This says, find me the inverse. Oh, let me go back. What I want you guys to notice from this, what was it? Filled in 2 and you got 4. Filled in the 4 as an x, and you got back a 2. What I want you to notice is, check out the x and y's. Aren't the x's and y's just switched? Yeah, the x's and y's are switched. So how do you find an inverse? This you knew was y. How do you find its inverse? You switch the x and y and solve for y. Subtract the x, subtract the x. X minus 12 is equal to negative 4y. Divide by negative 4 the whole thing. Okay, now looking at how they want it. They want it in y equals mx plus b, so I really can't write this that way. I need to write it this way. So that's -1/4 x plus 3 is equal to y. So I'd write in there -1/4 x plus 3 because they want it in slope-intercept form. So writing this, x minus 12 over -4 wouldn't work. Okay. All right. Switch. Okay, this is your y. Switch your x and y's. Oops, that's a y. Oh, come on. Jeez. And now solve for y. So subtract the 5. X minus 5 is equal to 5 halves y. And you guys haven't done much of this. When you've got a fraction like this, get rid of it by multiplying both sides by its reciprocal. Okay? So if you were to multiply straight across here, you'd have 10 over 10y. 10 over 10, then I wrote the 5. 10 over 10y, so that is just y. So in other words, the 2 cancels, the 5 cancels. Now distribute this inside. 2/5 x minus 5 times 2. Come on. What's going on here? What's going on here? 2/5. That's over 1. The 5's cancel. So you have 2/5 x minus 2 because the 5's are gone. Equals your y. So that's your inverse. Okay. And it's your y. -1/4 x plus 14. Switch your x and y. Subtract the 14. X minus 14 is equal to -1/4 y. Multiply by the reciprocal of this, which would, okay, -1/4, the reciprocal is -4 over 1. Do I need the over 1? No. So multiply each side by -4, and it's the whole side. And the -4 distributes in. -4x plus 56 is y. So that's your inverse then. Okay. Now, these ones are multiple choice. All the ones that came before this were lines. And that's what you do. Switch your x and y, solve for y. Same idea, but they're not lines. So let's talk through what you do. You got y is equal to 10 x to the 7th power. Okay? Switch your x and y's. And now solve for y. I know this power of 7 is going to be a little intimidating, but I got your back. I'm with you. That's held by multiplication. Before I can touch that exponent, I got to get rid of this multiplication. So I'm going to divide by 10. So I have x over 10 is equal to y to the 7th power. Now, stepping aside for a second. Let's say I had x over 10 is equal to y squared. What would you guys do to get rid of the square? You would square root it. There's a little 2 there. You'd square root it, and that little 2 indicates it's a square root. The square root would undo the square. So you'd have the square root of x over 10 is equal to y, because the square root and the square canceled out. Okay, this is a 7th power. A square root undid a square, so a 7th root, I know that's a little weird, is going to undo a 7th power. So you have the 7th root of x over 10 is equal to y. And then you look through and see which one it is. And it looks like this one. Okay, so let's try this one. So this is a y. Y is equal to 9x minus 2 in parentheses. Switch your x and y. Solve for y. You could distribute this in, but I think it's easier if you just divide the sucker out. It's up to you. It's you guys decide. Okay, if you'd feel, how about I do that? 9y minus 18. Okay, I'm going to add the 18 over and divide by 9. Now, be careful, you can't cancel that 9 and 18. Okay? Now, initially, none of these are written there. Okay? So you have to get a little creative with how you're looking at it. Now, my first instinct was to do it differently. This is fine. This is an okay answer, but we're not seeing it. So let me go back to what I was initially telling you to do. Looking at that. So I have x is equal to 9, y minus 2. My initial gut reaction was don't distribute it in, divide it out. And you've got x over 9 is equal to y minus 2. To finish, just add 2 to both sides. Now this adding 2 doesn't go to the 9. It's x over 9 plus 2 is equal to y. And I think this one is sitting there. It's right there. Now let me show you that this is the same. If I gave you 4 plus 6 over 2, would you guys agree that's 10 over 2, which is 5? Yeah. Now split this. 4 over 2 plus 6 over 2. Isn't that 2 plus 3? 2 plus 3? That's 5. You can split a fraction when it's adding or subtracting on top. You can't split it when it's adding and subtracting on the bottom, only on the top. So that's x over 9 plus 18 over 9, which is x over 9 plus 2, which is the same thing as we got down below. Okay. All right, y is equal to x minus 7 cubed. There's nothing outside the parentheses I can touch. I can't touch that subtracting 7 until this exponent's gone. You get rid of a third power by taking the third root. Oops, I didn't switch the x and y's. X is equal to y minus 7 to the third. Okay, now I can take the cube root. It's called a cube root. Third root, cube root, whichever way you want to call it. So I have the cube root of x is equal to y minus 7. And now you can add the 7 to the other side. And that doesn't get added under the root. It's outside the root. That's why I put that little tail on it. So there's no mistake that plus 7 is out of the root. And now let's look. It's right there. Okay, because it's outside the root, not inside the root. Okay. So let's look at this one. Okay. Y is equal to x minus 7 over 7. Switch your x and y's. First thing you do, get rid of this dividing by 7. Those cancel out. And you've got 7x is equal to y minus 7. Now just add 7 to both sides. 7x plus 7 is equal to y. Right there, first one. Okay. All right. Y is equal to, this just the x's in the square root. Switch your x and y's. Subtract the 10 before you can get rid of that root. X minus 10 is equal to the square root of y. Now, we saw a bit ago, say 5 is equal to x squared. You would get rid of a square by square rooting. Well, what gets rid of a square root? A square. Square both sides. This parenthesis is important. Square both sides. Okay. There it is right there. Okay. All right. Okay, this next one. So we've got y is equal to the cube root of x plus 5, and just the x is under the cube root. Switch your x and y's. Get rid of the 5. So x minus 5 is equal to the cube root of y. And in this one, you got rid of a square root by squaring both sides. You get rid of a cube root by cubing both sides. So you have x minus 5 cubed is equal to y. Boom, there. Okay. All right. This sucker, a fractional exponent. Well, let's just work with this for a second. You know you're supposed to flip or switch the x and y's. Okay. Let's look at what we need to do to get rid of that 1/5. Okay. When you guys had a previous problem, say it was x plus 5 is equal to the cube root of y. You guys would undo this cube root by cubing. You would get rid of it by cubing. Okay, these would undo each other. Well, it turns out a cube root is the same thing as y to the 1/3. So when you raise that to 3, these actually then multiply to each other. I know this is a lot. 1/3 times 3 is 1. Oops. Hey, if I cube the left, I got to cube, or cube the right, I got to cube the left. Okay. So this has a 1/5 power on the right. To get rid of it, I raise it to the reciprocal power. And you really don't need the 1 in this case, so it's x to the 5th is equal to y plus 8. Subtract the 8, and you get x to the 5th minus 8 is your y. There we go. Okay. I think that's the end. I think. Let me flip. Yeah, I think it's the end. Thank you guys for your time. Have yourself a great one.